In this video, let's now take a look at the first law of thermodynamics. First, let's talk about the concept of the internal energy U. The internal energy U of a system is defined as the sum of the kinetic energy and the potential energy of the particles comprising the system. So U is summation of all the kinetic energy plus the summation of all the potential energy of the particles of the system. In some ways, one can look at the internal energy as the total energy of the particles that's making up the system. The first law of thermodynamics tells us that the change in the total internal energy of the system, delta U, is just equal to Q minus W. Q, heat, heat gained or heat lost by the system, minus work done by or work done on the system. So Q is basically Q gain minus Q loss. So Q gained by the system and heat lost by the system. So Q gain, Q loss minus, meaning if the heat gained by the system is greater than the heat lost by the system, Q is positive. So overall Q, heat flows into the system. On the other hand, NQ is positive. On the other hand, if Q loss is greater than Q gain, so Q gain minus Q loss, if Q loss is greater than Q gain, Q will be negative. Overall, the heat flows out of the system. But you'll recall, in the previous video, we talked about the sign convention for Q. If Q is positive, the overall behavior is heat is gained or heat flows into the system. But if Q is negative, the overall behavior is Q flows out of the system. On the other hand, work, you have work done by the system on the surrounding, and you have work done on the system by the surrounding. Work, total work, is equal to work done by the system on the surrounding minus work done on the system by the surrounding. If work done by the system is greater than work done on the system, W is positive. So overall, work, the system performs work on the system, on the surrounding. Sorry about that. On the other hand, if work on the system is greater than work done by the system, W will be negative. So overall, W is negative. Overall, work is done on the system by the surrounding. So again, first law of thermodynamics, the total internal energy may change when heat is added or removed, or when work is done by the system or on the system. Delta U is equal to Q minus W. Unlike Q and W, however, the change in the internal energy, delta U, does not depend on the path taken. It doesn't matter if the path taken from initial state 1 to final state 2 is 142 or 132 or 12, the system will undergo the same change in internal energy. Delta U 132 is the same as delta U 142. It's the same as delta U 12. All you need to consider when talking about delta U is the initial state and the final state. Unlike Q and W, as we talked about, as we have covered in the previous video, when analyzing Q or analyzing W, you need to consider the path taken by the system from initial state to final state. There are a couple of special cases of the first law of thermodynamics. First, you have the cyclic process. Any process that eventually returns a system to its initial state is called a cyclic process. Since initial state and final state are the same, internal energy state 1, internal energy state 2 are the same, meaning delta U is 0. And since delta U is 0, 0 is equal to Q minus W. Q is equal to W. If a net quantity of work is done by the system during a cyclic process, an equal amount of energy must have flowed into the system as heat and vice versa. So if the system performed 10 joules of work, 10 joules of heat must have flowed into the system to account for the work done by the system for a cyclic process. The other special case of the first law of thermodynamics is an isolated system. An isolated system is one that does not interact with its surrounding, meaning no work is done on the surrounding does not perform work on the system, so W is 0. No heat flows into or out of the system, so no heat flows into the system from the surrounding. No heat flows out of the system to the surrounding. Q is equal to 0. Since W and Q are 0, delta U, which is equal to Q minus W, 0 minus 0, delta Q is equal to 0. So if the problem tells you the system is isolated, automatically the delta U is 0. The internal energy of the system does not change. The internal energy of the system is constant for an isolated system, which is basically what we have for what we got or saw when what we saw in the principle of conservation of energy. So that's it for now. In the next video, we'll look at the different thermodynamic processes that a system may experience or undergo. Thank you for watching.